Now we're going to go over solution stoichiometry and forming precipitates from the Chapter 4 packet. We're going to use this problem which has 100 milliliters of a 1.5 molar calcium chloride solution reacting with a 50 milliliters of a 1.0 molar solution of sodium sulfate. The first thing you want to do is write the CME, which is the complete molecular equation, which is going to be a double replacement reaction. So we're going to take our calcium chloride, CaCl2. That's going to be aqueous and dissolve because of Brickell's trickle, except for the happy tickle. Then we got sodium sulfate, Na2SO4. That dissolves because of group 1 and because of the capacitor pub hog 2. It's going to be a double replacement reaction, so calcium is going to go with sulfate to make CaSO4, which is insoluble because of the capacitor pub hog 2. And it's also going to make sodium chloride, which is soluble because of group 1 and Brickell's trickle. Of course, I put these together as CaSO4 because Ca is plus 2 and sulfate is minus 2, so they match. Sodium is plus 1 and chloride is minus 1, so they match as well. Next, of course, you're going to need to balance the equation. So you're going to need a 2 in front of the NaCl, and that'll balance the equation. All right, whenever you do solution stoichiometry, you always need to work in moles. So because I gave you the molarity and the volume, you could solve for moles, and molarity and volume you solve for moles, and then you simply copy those moles down underneath the starting solutions. So the calcium chloride is going to be 0.150 moles, and this is going to be 0.050 moles. And this looks like a limiting reagent problem now because you have both reactants. So ICF. This is going to be 0 at the end because nothing has been formed yet. Okay, so now what we need to do is we need to figure out which one is the limiting reagent. They both react in a 1-to-1 ratio. So, since they're both in a 1-to-1 ratio, you simply need to see which one runs out first in the same ratio. So 0.15 divided by 1, 0.15 divided by 1 times 1 is 0.15. We have not enough of this, so we have to go the other way. 0.05 divided by 1 times 1 will give you the right answer of 0.05. So minus 0.0500 minus 0.0500 plus 0.0500 and plus 0.100 because of this 2. You have to be careful. So now when we're all done, we're going to be left with a little bit of calcium chloride, 0.100 moles, no sodium sulfate. We will have 0.0500 of the calcium sulfate and 0.100 moles of the sodium chloride. All right, so now what we need to do is we need to find out in part B how much solid product is formed, which is the precipitate. So that is the 0.05 moles. And we can circle that. And then, of course, you could convert that into grams. So calcium sulfate is going to weigh 40.1 plus 32.1 plus 4 times 16, which is 64, and that gives you 136.2 is the molar mass of that. So if you multiply that by 0.05, you will find out that that's 6.81 grams. Because we took 0.0500 moles and converted moles into grams. And that's going to give you the grams. Okay, the last thing in part C is find the concentrations of all of the ions in the beaker after the reaction is complete. So we need to look for all the leftover ions. Molarity is equal to moles over liters. So what we're going to do is find all the leftover moles of each of the ions. So let's start off with the calcium. 0.100 moles of calcium chloride is left over. Since there's one calcium in that, there are going to be 0.100 moles of calcium left over here. There will be no calcium left over here as ions because remember it made a precipitate. So this precipitate is not going to dissociate. So this calcium does not count as ions because it's all part of a solid. So the only calcium we have is 0.1 moles, and then we want to divide it by the total volume. The total volume is going to be 0.1 liters over 0.05 liters. So when you put that together, that's going to make 0.150 liters. When you take that fraction, it's going to be 2/3, which is going to be 0.667 molar calcium chloride. That's going to be, calcium. That's going to be floating around in the beaker right here. Okay? Now what we're going to do is we're going to take the next ion, which is chloride. So chloride is going to be left over from here, but remember, there are 2 chlorides in this, so it's like bikes and tires. There are 2 tires in every bike. If I had 100 bikes, I'd have 200 tires. So this is going to be 0.1 times 2 for that chloride. And we're also going to look at some chloride left over right here, and that's going to be 0.100. However, we're not going to use the big 2. The big 2 only is used up to the coefficient line. So do not use that past the coefficient change line there. So there's just going to be a plus of 0.100 from that. So that's going to be 0.300 over 0.150. Should be able to do that in your head as a 2. Next, we're going to look at sodium. Sodium is left over not at all right here because it was the limiting reagent, and it is over here. Now, bikes and tires, there's only 1 sodium in here, so that means 100 NaCl's would have 100 sodiums. So this is going to be 0.100 moles of sodium over the 0.150 total volume. Again, that's 2/3, so that's 0.667. And lastly, we're going to do the sulfate. The sulfate ran out over here, so there's no sulfate, and there's no sulfate count from here because remember, that's a solid, and solids don't dissociate. So actually, the sulfate is the limiting ion in this reaction, and that would be 0 for the final concentration.